Hello, Robocon India participants. This is Prasanna Deshpande from MathWorks. Welcome to the second YouTube live session on Robocon India. We had our first session on December 7th. In that session, we covered three main points: modeling the disk throwing mechanism, adding computer vision to your robo, and implementing your MATLAB and Simulink developed algorithms on your embedded hardwares. In today's session, we are going to discuss about winning strategies for Robocon 2017 along with the referees. Let me introduce you to today's guest panel. Today we have Professor Anant Chakradev, who is Dean Director of Design Habitat of MIT Institute of Design. He is also a member of Organizing Committee for Robocon India and is one of the main referees for Robocon India. I'm sure everybody knows him very well. We also have Prashant Rao, Head of Customer Facing Engineering Teams at MathWorks India. Prashant is the main referee or main judge for the MathWorks competition, which goes along with Robocon. Let us get started with the session right away. And I'll start with Professor Chakradev. Professor Chakradev, you have been, you're always there onto the field throughout the competition. And you have seen multiple years, you have seen the students for multiple years. So what qualities have you observed in students of winning team, in basically operators of winning team? Any piece of advice from your side, specifically to the operators?
Yeah, you rightly said that I'm observing all these students for almost 16 years now. And the important point which I would like to mention here is about operator, and that is, see, the operator has to be a person with very cool head. He must have the best possible temperament amongst the group, because it's about playing. It's about playing any game. So he need not be a technically qualified guy. If he's there, that's good. That's the best part. But even if he is not a technically qualified guy, doesn't matter. But he must be having a good hand on console. Like if he is very good in video gaming, that's the best qualification to become a operator. But he must have the best possible temperament, and that's the most important quality, I feel.
Thank you, sir. Prashant, we have been we have been watching Robocon for like multiple years now, and I know that you are also judging and watching many other student competitions. What is your take or your opinion about this Robocon theme?
Yeah, I think, well, thanks a lot, Prasanna, and thanks a lot, Professor Chakradev, for joining us this afternoon, this evening. And thanks a lot to all the participants as well. This year's theme sounds or looks to be quite challenging. I mean, we saw the last year's theme, we saw the theme the year before. Essentially, there are a couple of, I think, things that are within, let's say, an operator's or a team's control. And there are a couple of things, from what I gather, from what I understand, is outside of one's control. For example, we're throwing the disk to land at a specific point. You can control all the way till the point that the disk is released. What happens after the disk is released and it's flying is theoretically, or well, it's kind of like outside of our control. You have nothing that you can control at that point in time. So I think it's important to be able to model that kind of behavior, to understand what are the various flight paths of a disk, how it could fly, what are the potential variants or variations that one can have, so that you can actually land the disk within that specified space. So I think in this year's theme, there are a couple of challenges, which is always a good thing, right? We're always looking for things that are challenging us. So there are a couple of challenges in the theme, in the sense of how do I model, or how do I actually understand the flight path behavior and understand where the disk is going to land at that point in time.
Yeah, actually, let me add something into that. When it comes to trajectory of the disk, and when it comes to the weight of the disk, or the push with which it is thrown, there are some other components which also come into picture. Let me assure you that there will not be any wind component present there, because that will not have any impact on throwing of the disk. But yes, there are so many other things which come into picture, and if it is simulated properly, well in advance, instead of just relying on trial and errors, it will be a good thing for all the teams.
Yeah,
Yeah.
thank you, sir. So, I mean, right away, this actually gives us segue into the next section, which is basically winning strategies for Robocon. So,
Mhm.
in the previous session, we have tried covering a number of technical aspects related to
Yeah,
the competition.
yeah.
And we are definitely sure that it's not just about being technically competent. It's not just about being able to model the robot. It's about being reliable and quality and a number of things. Even mind related issues like peace of mind of the operator and a lot of things. So, what according to you could be like winning strategies for this theme?
See, first of all, students should understand that it is a competition. So, when it is a competition, one must attempt that competition to win the competition. And for that, certain strategies, not positive strategies, I would say, not negative strategies should be there. So, first of all, students must focus on their own machine instead of, finding out the lacunas and the issues related to someone else's machine. They should focus on their activities. They should see that all the components, all the circuits, all the codes which they have written are working fine. Because what happens is, in the anxiety of the competition, students start making mistakes. So the entire group has to keep their head cool without any disturbance. They should not compare the other team's performance in the practice field and get deviated from their own preparation, because many times when they come to the practice field, they start observing other machines, and then they want to do so many things in 2 3 hours which they have, and then the whole thing is messed up, and the whole thing goes on toss. So my advice will be not to try any new thing at last minute. Whatever you have designed, whatever you have manufactured, be confident about that, and perform with whatever you have brought in. At the max, what you can try is improve on the speed at last minute. But no new code, no writing of new code, no development of new circuit, no development of new mechanism, nothing should be tried at last minute. At last minute, only chaos can happen, nothing else can happen. So that is the important advice to all the teams. Second important thing is, you can have different strategies for league matches, super league matches, and quarterfinal onwards, because league and super league, you have chance to fail, you have chance to make mistakes. But when you go to super league onward, when you go to quarterfinal onwards, it is you don't have any chance. If you fail, if you make a mistake, you are out of the tournament. So whatever improvements, whatever speed related things you are supposed to do, you can take those risks only when you go for quarterfinal, semi-final, and final. Otherwise, play safe when you are in league and super league, so that you go on acquiring points. In this game, there is a lot of importance for points. So go on acquiring points till you are in league and super league, and do whatever you want when you go to quarterfinal, semi-final, and final, because then it's a life and death. Then you can use all your energy, but till that time,
Yes.
have cool.
Sir, on the same lines, we have a live question. Basically, it's being asked if what will be a better aiming for upper A. Upper A is like a disc on every spot, every pillar.
Yeah.
Will it be like landing maximum discs on the center platform, or how about it?
No, upper A is defined very clearly. I suppose there has to be one disk on every, every platform. So again, it's a strategy of the team whether to go for that final goal or final aim, or whether to try putting more and more disks on various platforms to earn points, because every team will not have all those capabilities of pushing the disks from opponents and putting their own disk. It requires different type of skill. So depending upon the preparation of the team, they can decide whether they want to earn points or whether they want to go for the final this thing. But when you are in quarterfinal, semi-final and final, my request will be to go for the final goal and not go for earning points. That's not a good thing. You are here in a robotics competition. You must have best possible automation to win that game. And don't just count the points. That will be a wrong strategy quarterfinal onwards.
Right. So one more
Just to
question.
add on to that,
Yes,
yeah, I think sir, you make a good point, because essentially the team that has that winning strategy would be the one that goes for taking it all at the end. And if a team, let's say even if the majority of the teams are doing point winning, you will see the team that goes for the overall win be at the actual win. They will have the winning strategy. That is key. I agree with that completely. I think we saw that in the last competition last year as well.
And believe me, every year there is only one strategy which works and which helps the team to win the game. What is that strategy? Time will decide. But there are no multiple strategies which help students to win. There is one disruptive thinking which helps that team to work. So look for that disruptive thinking and not for counting the points.
Absolutely.
Yeah,
I
can't agree more.
I go back to the theme. The theme is here. It's ASOBI,
Yeah.
which I was just looking, and it's a playful, unique, original robot designs and strategies, and that is key. So not to copy other designs, but really think of something that's unique and something that actually works for you as a team, I would say.
Yes.
Can't agree more to this.
Right.
Yep. So I mean, as long as you can actually put a disk on every pillar, you need not apply any negative strategies as well. Just do your own game and you're the winner. That's great.
But
Sir, before we
good thing about Robocon is that we have come back to a game wherein I'm allowed to disrupt the opponent team. I'm very happy with that, because otherwise, the game was like I play in my zone, you play in your zone, and the fastest would win. I'm happy that it's real competition happening. I'm very happy.
Yeah.
Yeah, that's great. We have one more question. Now, I'm not too sure if it's possible to answer it right away. The question is, can we have a camera on top of the arena?
Every year, generally, they put one camera on the top of the arena, because they work with 5 camera to 6 camera setups. So generally, they put at the top. But that might not be of any use, because we don't refer any cameras. We don't we don't operate like a third umpire in other games. So we prefer giving decisions on our visual capabilities. But yes, there is a camera always on the top.
I guess Nilesh's question is more from building a strategy. Maybe he wants to see what is happening on the field, and the camera will be like fed back to his robotic system. I mean, is an individual team allowed?
We are not allowed to put any camera anywhere. No.
Okay.
That is not allowed.
I think this clarifies his question. That's great.
Yeah.
So basically, every part of the system, whatever you're using, should be on the robot itself.
Yes.
So you can't have another camera or another post or something like that, or a third person operating it.
That is treated as communication from outside, which is not allowed.
Yes.
Right.
Everything has to be contained on the robot. Yeah, that's basically the theme that we have. Yeah.
Right. And every year for Robocon India, we also see that the operator plays a key part. The operator always plays a very key role, because we have a lot of manual robots. So what are your thoughts on, not having operators, but offloading responsibilities of operator?
I would say that operators should have minimum tasks to perform. He should be allowed only to do what he is supposed to do instead of juggling with checking circuits, adjusting mechanisms, doing this, doing that. Operators should focus only on few activities. It can be ideally one single activity which he is supposed to do, but if not possible, at least 2 3 activities he should be doing. Other than that, he should not be given any other task, because then if his focus gets diverted, then probably he will not be able to perform. So the machines are supposed to be designed in such a way that there should be minimum intervention of the operator when the game is on. Ideally it should be fully automatic, but if not possible, there should be minimum intervention.
Yeah, I agree. I mean, just looking at the way automation is going in industry as well, right? I mean, we are offloading tasks from operators. Let's say aircraft, for example, are handling more and more tasks autonomously on their own, and where the pilot becomes more a manager of the system. Think of that as a concept. You know, if your robot has to move from point A to point B, give the operator maybe a single button so that it moves from point A to point B. Don't make the operator first press an X direction button and then a Y direction button and then a rotate button or whatever. You know, it's probably something that you want to offload as much as possible from the operator, so that the operator can think of the things that only the human being can do in such situations.
See, many times there are many teams which do hard coding as per the path which is prescribed, and the operator is simply a spectator which runs behind the machine. So operator is supposed to come in action only when there is an emergency, and when the control has to be switched on, manual control has to be switched on, and the control is to be taken over from fully autonomous to the operator's side. So many teams do that these days. Maximum teams should aim for that. That's what my feeling is.
So
I mean, these are things that where human error is reduced. Sorry, where human error is reduced, especially during a competitive situation, you really want to ensure that you have a repetitive environment, so something that you can repeat over and over and again. So repetitive tasks, things that you know have to be done a certain way, should be automated. There's no need for a human being, or let's say an operator, to doing the same tasks again and again and again, right?
One more word of caution to all the teams. See, it's March first week, so temperatures go up in month of March in Pune also, and especially the electronic systems or electronic parts start malfunctioning as the temperatures go up. There is a difference in temperature in the practice field as well as in the main game field. Even though we try to maintain the same conditions, but there is always a difference. When the crowd comes, again the temperatures go up. So one will have to think about all these aspects and then make the machines in such a way that it is not related to any changes in temperature or any changes in other conditions, and then it will function. Repeatability of performing all those tasks is very critical. Students should try that machine in all adverse conditions for at least 1,000 times. And if at 1,000 time it works, then they should be happy. They generally are happy with first or second attempt, and that's the problem.
yeah, so I can't stop bringing about a little bit about MathWorks competition here, because at MathWorks competition we are really focusing about building robust systems. I mean, frugal engineering is good to start with, but when you want to win competitions repeatedly, reliably, you really need to set up a design process, and that's the MathWorks way of encouraging student teams to go ahead with a methodical process. So just a bit about MathWorks competition. We are basically focusing on two things. One is implementation or modeling of functionality, which basically allows you to experiment with the functionality. You can simulate various scenarios, which includes various temperature conditions, various environmental conditions. And secondly, about prototyping functionality onto hardware, because once you invest a lot in building or designing your systems, you can make use of all those designs and basically generate code, or basically you can target your hardwares. So that's where MathWorks competition is independent of your team's performance in Robocon,
Okay,
because we
right.
want to promote this automation. We want to promote this following methodical design approaches.
Yes, absolutely.
Uh,
Couldn't agree
so
more.
uh, before moving on, I just have one more question. So the student is asking both of you whether what would be percentage of fully autonomous robotic systems in this year's competition according to you, because he feels this theme is little challenging for automation. And do
I
you really think fully automated system would win this competition?
Certainly, yes. I always believe in complete automation, and there is nothing existing in the world which cannot be automated. It's possible. Every time when we declare the theme, we feel that it is difficult to automate, and every time we see that in international competitions, autonomous machines perform. So I fully am confident that it is possible. But considering the Indian scenario and considering the limitations which our engineering students have in terms of equipments and labs, I think more than 50% teams will come with manual machines, fully manual machines.
Yeah. I think the important thing, let's say, for what's a takeaway for a team, or if you're developing your system, is to really think about which elements of your design or which elements of your system you have to automate.
Yes.
And make a conscious decision of, well, this is what we need to develop to be able to automate this part. I'm fine with a manual control. We've got this running or this ready. On that front, also think about incremental developments. You probably have a design or something working from last year. Use that knowledge, use that code or that model or whatever it is necessary, and bring that into this year's design, so that you can incrementally develop and then and improve on that. That's probably part of an overall engineering process. Yes, we do want unique and original designs, but evolution on this actually then results in you getting to a better design overall.
Yeah, most of the teams, knowing that there was in earlier Robocons, I think 3 years back, there was an activity of throwing something on the planet. So it was a planet Earth. So many teams have tried throwing activity, but the catch there was many teams were using vacuum cups so that the thing will go and land properly. Now here you don't have that facility of using vacuum cups. So even if you know how to throw, you'll have to find out some way of retaining that disc on the platform. So there are certain challenges which every team will face. But my suggestion also will be same: try to automate maximum possible things. It's experimentation. You are learning something out of it. You can very easily do manual machines, but it will not add any value to you as an engineer, and it will not take you anywhere. So please try to automate.
Yeah, and to add to it, actually, we want you guys, students, to win international Robocon. Robocon
Yes.
India is, yeah, of course, that's an achievement. But then we need an international Robocon winner from India. Unless you start automating stuff, it is not going to be possible.
Yeah,
Uh,
I agree.
yeah.
Go ahead.
Yeah, so actually there is one more question, and the question is, will new Frisbees be provided for every league match?
I'm not sure about that. We had a lot of discussion on that. For your information, we will be ordering for more than 2,000 Frisbees. So for every match, if we are, and The covering on that Frisbee is flimsy, so it's by design. We are not done anything to that. So there is a big chance of getting those Frisbees damaged almost in every game. So we'll try to supply a sufficient number of Frisbees. But my advice will be for practice field, you bring your own Frisbees so that we can save on those good quality Frisbees for actual matches. But yes, we'll supply and we'll try to supply as many as required. Have I answered the question in right
Yes.
way? Okay, fine.
Yes, sir. I think that's a great answer.
Mhm.
So another interesting question is which element of the system are you finding hardest to automate?
Probably. See, it's. I think the location of the platform, it's easy to recognize. So that part, so your maneuvering or the movement of the machine on the field, it's possible to automate. Even locating the platform height and adjusting the machine to the trajectory, that is also possible to automate. In previous Robocons, many teams have done that with some or the other technology. So I don't think any act is not possible to automate. Almost everything is possible to automate. It depends on what resources you have and to what extent you can go for automation, and does your financial budget permits to go for that. So it all depends on that. So you please go for optimization, so that as he said rightly, some things you can automate, some things you can rely on manual operator. But I feel everything is possible.
Sure.
Yeah, I'll add on a bit.
Hmm.
If I may, I'll add on a bit over here. I think so. Typically, when we work in engineering processes, when we work with customers, we can see this. The challenge typically is not about automating or developing, control mechanism or code or software for one specific function or functionality. Modeling that or simulating it or running it or even writing the code for that. That is, of course, it's challenging in itself. There is work involved, but that is a straightforward process. Things start happening, things start going wrong, so to say, or become very challenging when you start putting things together. These elements of your system need to start working together and working in a real world environment. That is when things start becoming a challenge. That's when you realize, oh, this part is not working the way I intended it to. This part is actually affecting another part of my system, etc. I'd say, bringing those things together early and running your system as a whole system at an early point in time, as early as possible. So, developing a system, running these, modeling it, running simulations, getting to know what is my system doing, what is happening behind the scenes, and testing it. As Sir said, up to 1,000 times, testing it in various different scenarios in different situations. That is, I think, the key. So really moving away from I have one functionality and I tested that, to really bringing these together on your final system and testing that system out. The team that does that early on, the team that has that, will have the most robust, most reliable system on the day of the competition, and will be able to concentrate on developing strategies to win, rather than thinking about how do I get my system running on those final
One
days.
more thing is, I think modularity is very important in this entire activity. Number one, you must develop systems in such a way that in lowest possible time, you can change the system on that machine. Second thing, when you're trying and testing the machine for say 200 times, 300 times, you must do failure mode analysis of that entire because finally it's an assembly of so many things. So you must do failure mode analysis. You must identify the parts which are liable to fail, and you must have substitute parts ready well in advance in numbers. And the changeability, I mean, the changeability in shortest possible time should be achieved. So such things are part of the designing process. So for design, when you design a machine, it's not simply designing for that task. It's designing for maintainability. It's designing for serviceability. So all those aspects are to be considered, and that is why it becomes a very challenging task. So don't make jugards. Jugards are not expected. It's a robotic competition. You're supposed to make fully functional automated machines which run on their own. So entire thought process has to be in that direction. Otherwise, you try it for 1 month, 2 months, 6 months, 1 year also, even if you prepare for, it will not work.
I completely agree with this, sir. Just to take few specific things, if you are struggling with detecting the platform to see which one have your enemies team disks and all, it's basically a computer vision capability. You need to do color detection. In one of our blogs we are covering it, and in the last YouTube live session also we have covered it. If you are finding any problems, just get in touch with us, we can probably help you. Then accurate generation of trajectory, yeah, so that's going to be a problem because the disks are non-uniform. If you go for accurate estimation of trajectory, how it's going to be a little difficult. But then there are some variations in any system. You need to account for those variations by physical testing. So modeling, calculation followed by physical testing is what is the probably the key for automating the disk throwing mechanism. I think the discussion is going on really well, and I would quickly like to share my screen to basically to summarize. And before summarizing, I want to talk about one more point, which is basically just trying to stress the importance of uh, the MathWorks prize that we have been talking about. So basically, best usage of MathWorks tools award will also be given in this year's Robocon. And the prize money in terms of cash is really good. Like first prize is 35,000, second is 25,000, third prize is 10,000. We are getting good entries for this competition, and number of teams are using MATLAB and Simulink this year. We are really busy. In fact, we are not able to technically help all of them. That's the response we are getting for the competition and in general for usage of MATLAB and Simulink. So if you are really, you can think of basically using MATLAB and Simulink and putting your entry to MathWorks competition. Basically, you might have to write an email to support_robocon@mathworks.in. So that's our email ID. Basically, sir, I would like to thank you. This was a great discussion, and I'm sure it will be helpful for all the teams, not only for this year, but for many more years to come. Because as we have always seen, robotic competitions are year after year, they can reuse a number of things, they can reuse their experiences, their learnings, and finally they emerge out as a real winner team, as a real winning team. Having said this, are there any last moment comments?
I would say that only 1 month is remaining. So now once you should focus on testing and be sure that you come fully prepared. And best of luck. We are there to help you in whatever possible way. But be ready, be prepared. And challenges, I mean, it's fine to take up challenges. No need to have fear of failure. You can fail because you are students. So be ready and be confident.
I agree. Yeah, thanks a lot. And it was great discussing with you, Professor Chakradev, and Prasanna. Thanks a lot as well. And thank you to all the students who are watching. Best of luck for the final day.
Yeah, all the best for the final day, and see you in Pune on Robocon day. Thank you very much.
Thank you.
Goodbye.
Thank you.
Yeah. Bye.
Bye-bye.